Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 19th. Looking at significant wave heights for the South Pacific Ocean, we see an area of seas about 36 feet in the Southeast Pacific. Pretty decent size area, too, of coverage, and another system pushing under New Zealand with 40-foot seas aimed due east. This is part of a very active pattern that has been going on for a week now. Let's dive into the details. First off, we're going to go back in time and examine all the storms that have occurred since Monday, June 13th. Starting with the first system under New Zealand, 32-foot seas forming, quickly building to about the, about 38, 39-foot range, pushing under New Zealand, aimed pretty well up the Great Circle paths towards the U.S. West Coast. Continuing into Monday night, again, seas building to 40 feet. And we'll just watch this. It sort of, oops, we missed one there. That's part of a computer issue. But then seas continued at 40 feet across the Southeast Pacific, and this system faded. But another system formed right in its wake on Wednesday with 45-foot seas, continuing into Thursday. Southern California, right here about 118, 42-foot seas, and it faded and started moving out of the storm track. So that really is one system going from New Zealand to the Central Pacific, reorganized, and we call this system 1.5. Then redeveloping, moving east from there. Yeah, now let's go back a little bit in time. Another system pushed under New Zealand on Wednesday, 42-foot seas, and as you saw, it continued with 42-foot seas into early Thursday, sort of faded, then redeveloped yet again with 42, almost 43-foot seas on Thursday night, pushing better to the northeast, and then started fading on Friday. That was what we're calling System 2. Then System 3 developed right behind that on Friday at 18Z, 37-foot seas, but quickly built with 45-foot seas, and again, lifting pretty well to the northeast into Saturday 18Z, still with 45-foot seas into Saturday night, and then started fading. And now, here we are, Sunday, 18Z, and another system pushing under New Zealand. So the short of this, without getting into all the gory details, it looks like a series of solid, though not over-the-top storms, are pushing our way, because what you really want, if you examine the Great Circle charts, in fact, rather talking about the Great Circle charts, let's just look at them themselves. Here's Northern California or Southern California. Pretty much the same thing. Now notice the track on most of these systems is zonal, that is west to east, and the Great Circle paths under New Zealand, the zonal flow does pretty good. It pushes a fair amount of energy off to the northeast, but once you get over into the Central and Southeast Pacific, you really need storms that are tracking northeast, almost due north, to push significant energy up towards California, and even more so for Hawaii. Let's take a look at that. Relative to Hawaii, the Great Circle paths, when storms push under New Zealand, they really need to lift northeast to push large energy to the islands. And the same somewhat true for Tahiti, though not as much so because they are just closer and decay has a much lesser effect on the resulting sideband energy resulting from these systems. Anyway, let's do this relative to Southern California. We'll just sort of blast through here. Here's the first system as we see, and it sort of, again, zonal. And then here's its follow-on, the 1.5 storm. And again, see, it's strong, but here's the Great Circle paths. We're in the Southeast Pacific. Most of the energy pushing, probably 45 to 50 degrees east of the Great Circle paths. Only sideband energy to result. But then here's yet system number, number 2 under New Zealand. We'll go back just a little bit so you can see it pushing almost right up the Great Circle paths. But this is 6,500 nautical miles away from Southern California, and then there's the shadow that's right out in this region. So there's a little pulse of energy, then things go shadowed, then this system redevelops, and the good news is it's not shadowed, and this storm number 2 with 41, 42-foot seas actually lifts a little bit to the northeast. But here you go. This is a good example right there. There's the, what is that, about the 202 degree great circle path. And those arrows are about, I'd say probably 30 degrees off axis to the great circle path to Southern California. So there will be considerable decrease in size from what one would expect if it was aimed directly up the great circle paths. And then here we go, another system, stronger system, Friday. This was system number 3 with, what was that, 45-foot seas, aimed better, but still pretty much off axis. And then here we go, system number 4, organizing Sunday evening, and we'll just roll this out. But you see, it almost falls southeast, and again, not clearly up the paths to Southern California. Why? Far worse. Northern California, the same thing. Most of this energy, let's see where we go. Costa Rica, looking far better. Peru, well, as well, and that's probably the best selection we have right there. Cabo, better. Not horrible, but not great. Really, the focus is somewhere down here in Mexico, Costa Rica, that sort of thing. So, anyway, so the point being, swell energy, lots of it, overlapping swells, but less size than you'd expect. And the swells, they don't merge like let's say 2.5 second periods, 2.5 foot swells at 18 or 19 seconds do not combine to make a 5-foot swell. They stay pretty much separate. What you'd end up with, though, is more consistency. You'll have 2 swells from, if they're both in this area, this is just hypothetically speaking, 2 swells from 200 degrees, both of the same size, hitting at the same time, let's say, or close to the same time, but literally one set would be from, say, one of the swells, another set from the other swell. If you really want serious, and each set would have, let's say, 2 or 3 waves in it, maybe 4 waves, versus if you had a big system that was literally pushing northeast, you would have more size and you'd get a lot more consistency. You get 8 or 10 waves in a set. So the point being, again, sort of like the last swell, for the most part, low wave count per set, not as much size as you'd like to see, but still, great run of surf. We've had a wonderful week-long run of surf, but again, it wasn't, epic. It was 2 feet overhead in Northern California. Lots of fun, good time, but long waits between sets. Groups of sets would clump together and arrive, and then you'd have 40-minute lulls with not a whole lot going on. So probably more of the same expected, if not even more so, for this upcoming run of surf. Let's go take a look at the models, verify how accurate they were as compared to the JSON 2 data. So here we go, JSON 2 satellite data overlaid over hindcast wave models. We're starting here on 6C Monday, that's Sunday night last week. That first little system, storm number 1, 32-foot seas. JSON satellite says, let's make sure we're looking at the right coordinates, correct, 35 feet with one reading to 42.6 feet right there. So actually, the model was undercalling it, at least for a little tiny area. Let's see if we get it. And here's another better pass, 18Z Monday. The model said, 30, 32, 34, 36, 37 foot. And JSON 2 satellite says 15 reading average, 38.8, with a peak reading of 43. So again, besting the model. That is good news for us. And yet another. What are the odds that you get 3 passes in such a short period of time? 38, 39 foot seas forecasted here. The model projects, we'll see this track ran a little north of the core. The core was down there, but still 30, 32, 34, 36 foot seas, let's say. It said 35.5 with one reading to 40.6. So again, the model doing quite well. All right, and then we see, here we go, the system tries to reorganize again out here. What is that? 32, 34, 36, let's say 38 foot seas. And, but these numbers here are both for this system out here. So, but you can eyeball the numbers here. They're about 36 to 38 feet. So that looks about on track again. Here's, oops, and then we lost some. There we go. Here is system 1B. We'll just roll through that. We get no passes off of it. Here comes the next system. Actually, I'm going to go back just to check this guy as he comes under New Zealand here. No, so that, whoops, so that was it. There we go, 40 feet. The model says, and see, the problem is you have so many competing storms here, and you're at the mercy. But so which one's this? 51 south, 158. That's this one. It says 35. So this suggests the model was overcalling it, and that's 51, 59. Yeah, so right there. So this one is overcalled. It suggests 41-foot seas, and we're saying only 36 foot or so. Maybe we can get another pass. Nope. And as the system dies, 30, what is that? I'm not even sure this is the right pass. 142 and 47. Yeah, that's it. 35-foot seas with a max reading to 39. Now it's saying it's higher than what was, and that's probably about right considering the storm. You know, there's a bit of fudge in the numbers here you have to account for. This is really interesting here, too. See that? It's saying 30-foot seas right in there with a peak to 35 when the model only suggests 28-foot seas. So again, interesting bit of data, and where are we? I think we just rolled back. And the most current image, we're looking here at the final system here pushing under New Zealand, 18Z Sunday. The model says like 39, 38-foot seas, and this is really interesting. Max average measurement was 40.8 feet with a single reading to 46 feet, so the model's actually undercalling this, what we call system number 4. So the short of it is, for the most part, the storms, especially the early ones under New Zealand, actually look like they're doing a bit better than the model suggested. The rest of the data is somewhat inconclusive, but given the model's general trend lately, they've been fairly accurate. So I think one can assume that certainly swell is on the way. And specifically, the lion's share of this is relative to U.S. properties is heading towards California as compared to Hawaii. The profile generally is things kick off on Tuesday, Wednesday gets better, Thursday, Friday, Saturday, Sunday, very solid swell indeed, and likely more energy into Monday and Tuesday, but fading. So basically, another 6 to 7 day run of swell in the, let's say 1 to 2 feet overhead, and in Southern California, they're going to get more of this. You could get bigger swell at top magnets for mainly southeast direction swell. Let's go take a look now at the forecast. So everything we've talked about so far is storms that have happened over the past week, swell that's already in the water pushing towards us, and we haven't even begun to talk about what might be coming for the future. As usual, we start out with the forecast talking about the Jetstream. Jetstream, of course, drives the storm track and helps to support the formation of gales. We're looking for troughs, a dip. Actually, it's a push sort of to the north in the Jetstream. And here we see a bit of a trough in the West Pacific and another one in the Southeast Pacific, but winds not particularly strong, feeding either of those troughs. But as we get further into the week on Monday, a bit of a trough starts developing in the Southeast Pacific. Mainly notice the northern branch of the jet collides with the southern branch. You get just this little pocket of wind energy here at, what is that, about 130 knots or so, and more energy starting to build here under New Zealand. We'll roll this out, and all that starts feeding into creating a larger trough Tuesday into Wednesday. And look at this, you get this big, just beautiful looking trough setting up. Not super strong winds, but still 140, 130 knot winds over a broad area. And we'll roll this out more, and look at this. Then the winds start pushing almost straight from the south into Thursday and stronger into Friday. Where is that? Peaked out Thursday night at about 140 knots and barely in the Southern Cal or in the California swell window. And then a little bit at a time, a ridge starts building that would help suppress the formation of gales, where of course a trough helps support the formation of gales. And we'll roll this out, and then kind of a muddled pattern, though it looks like a bit of a trough trying to organize 180 hours out. Let's go take a look down at the surface. And as expected, here is our one gale under New Zealand, 50-knot winds, and then bits and pieces. This is actually, I believe, leftover from storm number 3 here in the southeast Pacific. What was that, 35, almost 40-knot winds. A little pocket here of 35-knot winds. And I roll this out, and we, again, this system out of the California swell window, certainly good for Central America, Mexico, Peru, etc. And our system under New Zealand continues, and yet another system here on Monday, 45-knot winds developing in that trough that we saw, and building into Tuesday, almost 50-knot winds. And there we got a little pocket of 55-knot winds. Now that's sort of, remember, the Great Circle tracks here run due north, so this fetch down here is good. This is kind of off axis, pushing more towards Peru, but swell potential for sure. This system moves out of the window, and then we have yet another broad system on Wednesday moving into the same area with 45 small pockets of 45-knot winds aimed almost due north. That's good, and lifting north, and more 35-knot winds, but 35-knot winds doesn't generate enough swell to do much. Also of interest, if you're into Fiji, check out this system in the Tasman Sea on Friday, 45, almost 50-knot winds, and a second pulse into Saturday, pushing off to the north. That's a good sign there. And then we have yet more fetch developing in the 35 to 40-knot range into Sunday and Monday. Let's go take a look at the wave models. And here we go. So remnants of storm number 3 fading out with 32, 34, 36-foot seas and just barely in the southern Cal swell window. And again, our other system pushing under New Zealand with about 38-foot seas. We're rolling into Monday. The New Zealand system fades out. Actually, it's holding together better than it previously was forecast. Another little system trying to organize here, certainly with 30-foot seas, but again, all aimed off to the east. Trying to get some fetch going here, 38-foot seas, 39-foot seas, but again, outside of even the California swell window, this is purely a chilly sort of storm. But then here we come with that broad fetch we saw, 34-foot seas aimed pretty well to the north on Wednesday, more so on Thursday. What is that, 34-foot seas? Probably a good little run of 17, maybe 18-second period swell from this system. If it develops, I mean, we're 100 hours out from that happening. And then things kind of back off. Oh, and let's go take a quick look at what's going on in the Tasman Sea. So here we go, starting... There you go, a small area, 32-foot seas on Friday, stronger to almost 36 feet on Saturday, and very close to Fiji. That should make for some rather large swell, depending on what the local winds do in Fiji. It either could be a mess or it could be quite large and maybe a bit on the unruly side. But much activity, still forecast. But it looks like things are settling down just a little bit as compared to the past week's run of swell producing weather systems. Let's go look long term. And of course, the transition from El Nino to La Nina continues. First off, we look for winds. This is from the TAO buoy array, actual buoys on the ocean surface. Trades, east winds dominate the Kelvin wave generation area, and for that matter, the entire equatorial Pacific. Much weaker, though, in the Kelvin wave generation area proper. That's about from 170 5 degrees north or south of the equator, out to about 135 east. We're not expecting a Kelvin wave to result. Notice there's even a hint of weak westerly anomalies, but for the most part, everything's neutral. Looking at temperatures here, you can also see cooler than normal surface waters in this area, the onset of La Nina. Let's dig in a little deeper. First off, we're going to look for wind anomalies, and again, in the past, here's past history, Kelvin wave generation area here. Blues are east anomalies. We want west anomalies. We went through a little pocket here of westerly anomalies starting in early June and just wrapping up. We honestly believe this was some sort of, I'll call it the active phase of the MJO that helped to positively influence the southern hemisphere. It's just more than coincidental that you have westerly anomalies that exactly coincide with 2.5 weeks of steady swell producing storms in the southern hemisphere. The issue is now here we are at current easterly anomalies taking over. Yes, there still is storm production in the southern hemisphere. There's the hangover from El Nino helping to goose up the jet stream. This is completely expected that the area under New Zealand and into the Central Pacific would be more active than normal this year. It typically happens after the winter after, or the summer after El Nino in the northern hemisphere. But now it looks like we're moving into a inactive phase of the MJO, at least according to this, with easterly anomalies in control for the next week. Looking at the outgoing long wave radiation forecast charts 2 weeks out, this helps us to determine the state of the MJO. Oranges and yellows in this area right around here suggest the inactive phase of the MJO. Clearly, the active phases hold up here in the Indian Ocean. The statistic model projects the active phase moving towards the West Pacific 2 weeks out. The dynamic model here, not so encouraging, suggesting the inactive phase fades. The active phase tries to make a push, but then just sort of loses it, and we get into this weak kind of neutral pattern. The phase diagram charts, again, assume you're looking down on the North Pole, and you move, and the active phase of the MJO moves from the Indian Ocean to the Maritime Continent, over the dateline, the West Pacific, over the Americas, into the Atlantic, back to the Indian Ocean, and just cycles continually around the globe in 4 to 6 week intervals, typically. The active phase of the MJO, per this, the ECMF model, is in the Indian Ocean, is expected to make it to the Maritime Continent, then move to the dateline and collapse 2 weeks out. The GEFS model suggests the active phase isn't supposed to make it to even the dateline. It's supposed to collapse in the Maritime Continent and get very weak and incoherent. The CFS model, which we've been using and actually does quite well, again, Kelvin wave generation area runs roughly these two lines right here. This chart goes past history from the bottom. Here was a westerly wind burst in February, another weak one in April. We just got through a little pocket of westerly anomalies. Again, this is what we think was responsible for the bout of swell production that has happened the past, actually storm production that's been happening the past 2+ weeks or so. And we'll overlay the MJO here. We were in what this model called the active phase of the MJO. No other models really picked up on it, but we think this is probably closer to the ground truth. Here's the current date going towards the future. A very muddled and weak MJO pattern is forecast with no clear signs, just some weak westerly anomalies, but really a neutral pattern, and then moving into a building easterly anomaly pattern in August into September. Overlaying the low pass filter, this is the black contours suggest or clearly indicate El Nino, and it's weakening from this point forward and all but gone by the end of August. So El Nino's influence on the southern hemisphere will continue to weaken as we move through the summer. The thought being that the first year we've actually had one rather southerly bout of swells about 3 weeks ago. Then this past week we had a more south-southwest bout, and we have yet this one last run that's coming. But the thought is after that, yes, we'll still have southern hemi storms, but you're not going to get the flurry of activity and probably not the magnitude that we're seeing right now. Of course, we could always be proved wrong. These sort of MJO influences just tend to be overarching general things. That does not mean that you cannot have very strong storms, but in terms of cycles of storms, the MJO seems to be a very good indicator both in the north and southern hemisphere, so we're going to roll with that for now. Next, we take a look at subsurface water temperatures, West Pacific here, East Pacific here, on the equator, and we see There used to be warm water all holed up here in the East Pacific, driven by El Nino. That has completely reversed itself. We're back to a normal pattern. Warm water holed up in the West Pacific, cooler water, relatively speaking, in the East Pacific, and the 28-degree isotherm cuts off at 158 here west, again suggesting during El Nino the 28-degree isotherm starts inching off over here, and it did during this El Nino, but it's collapsed back to the west. Actual water temperatures. Now this is actual anomalies, differences from normal this time of year. This is actually a little bit interesting. Yes, we have cooler than normal waters. It's like a cold water Kelvin wave, if there is such a thing. But the actual extent of these waters has decreased as of late. And notice that some not warm but neutral temperatures persist here off of Ecuador. There's this one little vent here, if you will, between about 130 west and 150, where cool water is making its way to the surface. You can also see that here in the another high-res version of it, we have our warmer than normal water in the West Pacific. Two little pockets here suggesting there's at least some, I wouldn't say a resurgence of El Nino, but the cool water is being held at bay. Now, this chart here suggests cool water makes it the whole way to Ecuador, but again, it's still venting up between about 125 and 150. This is the main vent port for La Nina, basically the La Nina cool pool. Next, we go take a look at actual, well, again, these are anomalies at the surface rather than subsurface. We see cool water developing along Peru and moving up off Ecuador, but it was actually much cooler the past 3 weeks or so. Things have actually warm water building just off the coast. The cool pool then continues off along the equator, a couple of degrees north and south of the equator, but this too has warmed as compared to what it was. It sort of lost its punch. Here's the trend up here for the past 7 days, and we see the cool pot. This was warmer last time we looked at it, but we see now that the cooling trend continues along here. The interesting part here is off Africa. We did have a mirror image thing going where it was cool off here, and typically when you see that, that suggests a couple of weeks later you get a pulse off of Ecuador. That has now warmed some, suggesting that maybe these pockets of cool trend might weaken yet more in the days ahead. And then finally, actual water temperatures, deviations from normal. We see warmer than normal water starting to build on the equator here. That if that holds, that would be bode well for hurricane production relative to the U.S. East Coast. For the U.S. West Coast, and here, this is the Nino main regions, temperatures are cooling, cooler than normal, but the general overall pattern here off of Peru, etc., is not as cold as it was a week, 2 weeks, or 3 weeks ago. It's sort of like La Nina pulsed, and now it's backing off and taking a break. Maybe that's because we've been through the active phase of the MJO. That sort of took the sail out, or the winds out of La Nina, figuratively speaking. But if the inactive phase builds in, then you'll see this area redevelop. Also of note, water temperatures off San Francisco are actually pretty decent considering how much wind that's been blown. And you can see water temperatures here suggest much the same, that we're still above normal. In fact, almost all the tropical Pacific is still above normal, as is the Atlantic. There is some, we're scratching our head a little bit. I mean, we're almost wondering if the climatology isn't off a little bit. You shouldn't have this much warmer water than normal from an El Nino, La Nina sort of perspective. But what's been happening is the oceans have been continuing to warm over the years. NOAA keeps updating the climatology to keep up with it, but they can't keep up with it. We think some of that might be going on, but we'll give it another 6 months before we would say that's definitely the case. And there's still some sense here of the PDO, active phase of the PDO. We've talked about that, still in play. Warm water off the U.S. West Coast, cooler water up here. And finally, how well coupled is the hangover of El Nino to the atmosphere? We look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you see negative numbers or a long run of them, that suggests the active phase of the MJO. If it's really long, it suggests El Nino. Currently, we see kind of a mixed bag, but the tendency tends to be pretty much normal or neutral until the 17th of June. And then we got 15.5. The 30-day running averages takes the noise out of this, suggests pretty much a neutral normal. We're near zero here, or just slightly hinting at a inactive phase of the MJO. The 90-day running average still hanging around -7 at -6.93. But again, this is a 90-day average, so data from 2 months, 3 months ago are still influencing this. The expectation, this will be working its way towards zero in the next 2 months. And the ESPI basically does the same thing as the Southern Oscillation Index, but just does it based on actual precipitation deviations in the same areas, roughly north of Darwin here and north of Tahiti. The current index is -0.21, which is basically the last we're moving towards La Nina. Negative numbers suggest La Nina, but basically it's neutral, suggesting a normal pattern at this point in time. We'll take a quick look at sea surface temperatures in the Nino 1.2 region. That's basically off of Ecuador between the Galapagos. Temperatures falling, still hanging in around neutral. All the other data pretty much suggests the same thing. And in the Nino 3.4 region, this is the area that NOAA monitors to really declare El Nino or La Nina. Temperatures started dipping in early June towards La Nina. Negative, not strong La Nina, but like -0.4 degrees. And then with the fading of La Nina, and we saw that in all the other charts where temperatures sort of lost some ground, the negative temperatures that is, and actually warmed up again into El Nino's temperature range at, what's that, +0.7 of a degree, and then as of today, half a degree above normal. So a little bit of a back fading of La Nina, and El Nino trying to exert its influence. Again, that suggests the active phase of the MJO, and that's what we think has been pushing the storm track lately. But we expect this to start falling and the storm track to start settling down. The forecast for the Nino 3.4 region, here we are in June, about neutral. The forecast suggests, and this is a bit of a backtrack for the forecast, it was suggesting we'd be down somewhere in here in early July. Now it's saying only at -0.3 degrees, but eventually working towards about a negative anomaly of 1 degree in the Nino 3.4 region, and holding there the whole way through the fall and the winter, and then starting to recover some. Here's a consensus of all models, both dynamic and statistical, and you can see the different plots here. But the short of it is you see this trend in June, July, August here towards negative, and then hovering somewhere around, just somewhere above a degree negative through December, January, and then maybe rising a little in February. If you scroll down here, you can see the actual data from each of the models, that is both the dynamic models and the statistic models, but all of them averaged together suggests, here we'll go, we'll just August, November, get a sense here of a -6, -7, -8 in about the December time frame, and then starting to come out, -0.8, 0.8 of a degree, which is not that strong of a La Nina. It's going to be really interesting to see how this plays out. If the PDO is in fact in the active phase, this is exactly what you'd want to see, kind of a light La Nina coming after a relatively strong El Nino. This would suggest that La Nina's influence might last for 2 or 3 years but not be that strong, and that the storm track might not be so negatively influenced over the long haul, and that the overall trend will be more towards stronger storms and more active storms. So to wrap it up, series of storms, swells actually we should say, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday starting to fade out, moving towards mainly California, very limited sideband energy for Hawaii. Most of this energy will be focused into Central America, let's say southern Mexico, Central America, into the Peru area. Good run of surf all along. Make the most of it, because the long-term models suggest, at least our interpretation of it, is that this pulse might be one of the last good long solid pulses. You do not turn away from a gift like this long run of swell. So make the most of it while you can. There certainly will be more surf to follow, but probably not as consistent and pronounced as what's coming. Nothing huge, but solid days of surf. Make the most of it. And we'll do this again next week. Same time, same channel. Thanks for watching. Bye-bye.